Okay, here we are. And the topic at the moment is similar figures. Just by definition, let's get a word. When they say similar, they mean same shape, different sizes. So here's two shapes. They look the same. They're definitely not the same size, but the question is, are they similar? So it has to be the same shape, different sizes. And it turns out that figures that are similar, the ratio of corresponding sides are proportional. So let me write that down. The ratio of corresponding, that means kind of matching sides. We'll do that here by example. Of corresponding sides, by corresponding I mean matching. The ratio of corresponding sides, that is of matching sides, is proportional. So let's see how that looks. So the little notation that goes along with this. Here I have two figures, and they're actually telling me that they're similar in this case, and so they're asking me to find the side that's missing. We'll deal with a slightly different case in just a moment. It's typical in geometry to label corners, vertices, with capital letters. And another thing that they often do, so that I know which side in this figure matches up with which side in this figure, is you'll do a little hash mark. So I can see that this side kind of matches up with this side, right? So I'm going to do one little mark there, and that indicates this side goes with this side. And I can repeat it for the other sides. So this bottom piece here should match with this bottom piece here, the way they're laid out. And we'll put 3 marks here to match 3 marks here. That way I know which sides match up with which sides. One thing that's critical is that you actually label appropriate sides. So what I want is I want to compare corresponding sides from this triangle with corresponding sides of this triangle. And I'll call this the small triangle, and so I'm going to do a labeling here. So I'm going to do the small triangle compared to the big triangle. We'll look at each piece individually. So I want to match this side with this side. Well, how should I label that? Well, this side is labeled A, B. That's on the small triangle. The same side on the large triangle is XY. And then I can continue this. I can see that BC on the small triangle is YZ on the large triangle. And I could continue around saying AC is proportional to XZ. But I just need to find X here. And I notice that I have 1, 2, 3, 4 pieces, and I know 3 of them. And that is enough to allow me to set up a proportion to solve for X. So AB is 9. Now I'm just plugging in the numbers. AB is 9. XY is X. BC is 7. And YZ, down here, is 14. So now if I do cross multiply, 7x is equal to 9 times 14. I'm not going to multiply it out because when I go to divide both sides by 7 to get x by itself, I notice that this right here, 14 divided by 7 is 2. 14 divided by 7 is 2. And so I'm left with 9 times 2, or 18. So because these things are similar, I know that this side here has a length of 18. And that's how I determined X here. So some of the variations in this you see is they'll give you two shapes like this. Now here you have to be careful because it looks like they've turned things around. This here looks like it's almost a right angle, but that doesn't look here. It looks like this angle matches more up with this angle. And so this time you just have to be careful of which sides match up. I won't complete this all the way, but I'll go ahead and set it up for sake of shortening the video. So I know that this, again, I'll do small triangle parts to large triangle parts. So I'm calling this the small triangle. I'm calling this the large triangle. And when I do that, I see that this side here, XY, can we agree that's the shortest side? Looks like it matches up here. That's the shortest side. Another way to see it, I can see that this x angle is between these two, and so it's going to have to be between these two measures here. So in this case, xy, the side xy, is going to match up with the side AB in this case. Okay, now I want this, so now I want the xz in this case, and you can see what they've done is they've turned this thing around. So xz in the small. If I rotated this piece around, that would give me this side here, AC. So you just have to be careful. Sometimes they rotate this. So what I've done here visually is I've taken this and I've rotated it so it matched up with these pieces on this side. And then I can go ahead and I can plug in my values now. So xy is x, AB is 72, is equal to xz is 12, and AC is 108. And I can go ahead and solve this. I'll have 108. X is equal to 12 times 70. Actually, now that I've got this out, I'm going to actually go ahead and solve this because that'll give us a chance to demonstrate some factoring. So I want to divide both sides by 108. And that allows x to be by itself. And now I have this mess over here. Well, that's 100 and I wrote 100. It's not 100. It's 108, isn't it? Well, I know that 108 is the same thing as 9 times 12. And I know that there's 12. And I know 72 is 8 times 9. And the beautiful thing about that is the 9's cancel out, the 12's cancel out, and I have x is equal to 8, which avoided me having to multiply 12 times 72 and dividing some larger number by 108. Okay, one other way these questions can come at you is the following. Is you're asked to determine if the figures are similar. So they give you a shape, and then what they do is they ask you to determine if the two sides are similar or not. So we could set these things up the same way, and I could see here this looks like it's been flipped over. So in this case, sort of B matches with Y. So if I do the small triangle again, over the large triangle, and I'll match up these parts. Remember, if it's similar, all the sides have to be proportional to each other. So I'll do this side first. So AB on this side matches with XY on this side. And then I'll continue down here on this right angle, what looks like a right angle. So that means BC should match up with YZ. And then I have this last side, looks like a hypotenuse here. AC will need to match up with XZ. So now all we need to do is plug in the values. So I have 3 over 21. And here I have 4 BC. YZ is going to be 28. And on this side I have AC is 5. This side I have is 33. It's kind of hard to compare, but let's see if we can simplify some of these things. Because I see that I can simplify 3 over 21, and that's, if I divide top and bottom by 3, this becomes 1 over 7. This is divisible by 4 top and bottom. If I do that, those are the same. So I can see so far, these two sides are proportional because they reduce to the same thing. But if I divide this by 5 to get the 1, I am left with 33 divided by 5. 33 divided by 5 is not 7. It's something. This would have to be 35. So because the ratio of all the sides is not the same, oops, I better move that up. Sorry about that. When I simplified each of these fractions, these first two, they matched up. So these two sides are proportional. But because this ratio is not 1 over 7, these sides are not proportional. So what do we conclude by that? We conclude triangles are not, I should say the triangle sides are not proportional. And because they're not proportional, so the triangles are not similar. You know, sometimes you might be asked to write it out this way, but this right here shows not proportional, so not similar. Well, there's a little introduction to similarity. The wrap up again one more time is all the sides, in order for the figures to be similar, is for corresponding sides to be proportional. That is, the ratios of them would be the same. Hope this helps. You have a nice day.